Yeah, I think if we had a sort of rational global democratic government, you could. Yeah, I know that's the best joke I've ever told in my life. But if we had a rational, global, beneficial world government, you can imagine humanity just voting like, let's slow down on AGI development while we kind of figure out how to make sure it's for everyone's good, and we'll accept the lack of some good things while we do things more conservatively. The world is very much not like that right now. We have an AGI race thrust upon us by US and Chinese governments, right? And it would have been Russian government too, if not the Ukraine war, right? I mean, I was with Putin in 2019. He gave a talk on AGI at the AI Journeys conference in Moscow, right? So I mean, the geopolitical realities are pushing us toward an AGI race. It's not written that centralized companies together with governments will win the AGI race. And I think the best chance the decentralized world has of winning is if a better way to do AI happens to emerge first in the decentralized world. Like I think if we're just playing catch up with transformers in the decentralized world, it's very hard to win an AGI race, although we can still do a lot of good, right? But if a better way to do things, like the next ChatGPT, but better, like pops up in the decentralized ecosystem, then the centralized world will be trying to catch up, right? And that's going to be it's going to be a better balance, right? And that's what I'm after with SingularityNet and Hyperon and predictive coding, and why I think collaborating with Kwaai on various things can be helpful also, right? So I mean, it is up to us to sort of steward the emergence of AGI and ASI in a beneficial way, and the people in this room at least have a leg up on most people, because we get that open and decentralized at least are very, very valuable ingredients.
Thank you very much.
Wow, thanks so much.
I want to do one question. Wait,
one thing I forgot to say. So there's a bunch of developers in here. I would encourage people to go and just play around with our Meta programming language. Like, it's open
before
source.
you leave,
Open source code, you can use it, and we could use more developers hacking on Meta.
it's my pleasure to announce that Kristi Noem was fired an hour ago. If you haven't. Serious. She literally was fired 1 hour ago. So things are getting better while we're here. Do we have time for one question for him? Please. Anybody got a great question? Because that was a lot to. That's a good one.
You know, the best place to find my papers would be a link that isn't that obvious. So if there's somewhere I can email, then everyone would get it. It would be great. I will do that, because there's a lot of information at singularitynet.io about what I'm up to and the things I'm doing. And there's hyperon.dev has links to all the code for Hyperon. But for my papers, I'll send you another link, actually.
Okay.
So
Thanks so much, Ben.
I've got a question.
I'm sorry. Yeah, you, sir?
Yeah. Me, sir. Yeah, my name's Riza Rasul. I'm asking for a friend. Gosh, you said you saw my presentation on fluidic neural networks. Yeah. I think we need to get a room, because this is this is like a pet project. We've got the director of research, Solomon Satori. He'll speak later on. We're almost scared to talk about this stuff. I gave a presentation on my vision, my insight, I guess, into how neural networks and quantum mechanics look very similar. The neural network and the wave function look and behave in a very similar way. You've got at one end, you've got an input, which is an observable. You've got an output, which is an observable. And in the middle, in neural networks, they call it a hidden layers. In quantum mechanics, it's called a wave function.
Sure.
And in both cases, the high priests of both disciplines say, you're not allowed to ask what's inside. It's unknowable.
Yeah, well, the thing that led me to fluid neural networks is the HJB equation, Hamilton-Jacobi-Bellman equation, which is a basic equation of optimal control, which underlies reinforcement learning. I mean, this equation describes the space of volume-preserving diffeomorphisms of a fluid evolving by Navier-Stokes equation. But the HJB equation, if you complexify it, also gives you the Schrodinger equation, right? So, I mean, the quantum math and reinforcement learning math and fluid dynamic math they're the same thing under some one-to-one transformations.
We need to get a room.
Get a room.
I mean,
Okay.
now
Because-
how to cash that out in a scalable way in practice is an interesting question. And I implemented one prototype of a fluid neural network and then haven't done anything more with it because I've got so many other things to do. And you may be in a similar position, but it's a very important direction. Yeah.
Okay.
Thanks so much.
Thanks. Okay.